For the first question, it asks us to identify which electrode will produce bubble of colorless gas. So to solve this question, first step is to identify what ion is present in both solutions. The solution used in this question is dilute sodium chloride and concentrated sodium chloride. So we go through dilute sodium chloride first. For dilute sodium chloride, the ion present is Na+, Cl-, H+, and OH-. And then we identify which electrode is anode and which electrode is cathode. So since electrode 1 is connected to the positive terminal of the cell, it is the anode. And the electrode 2 is cathode since it is connected to the negative terminal of the cell. And anode, as we know, anode will attract anions, which is negatively charged ions. So Cl- and OH- will be attracted to anode, and A+ and H+ ions will be attracted to cathode. And then we see the reaction that is occurring at anode. So at anode, we have Cl- and OH-. OH- ions are selectively discharged because the position of OH- ions in electrochemical series is lower than Cl-. Thus, OH- are selectively discharged. And half equation is OH- ion will produce oxygen and water. So oxygen gas is produced at anode. So at cathode, we have Na+ and H+. H+ ions are selectively discharged because the position is lower than Na+. So half equation is hydrogen ion will be producing hydrogen in the form of gas. So hydrogen gas is produced at cathode. Next, we'll go to concentrated sodium chloride. The ion present in concentrated sodium chloride is the same as in dilute, which is Na+, Cl-, H+, and OH-. And then the anode is electrode 3 and cathode is electrode 4. And the ions that is attracted to anode is Cl- and OH-. Ions that are attracted to cathode is Na+ and H+. Reaction at anode. So we have Cl- and OH-. Because this solution is concentrated, thus Cl- ions are selectively discharged. The half equation is like so. 2 Cl- ion will be producing Cl2 in the form of gas. And therefore, chlorine gas will be produced at anode. And chlorine gas is a yellow colored gas. While reaction at cathode, H+ ions are selectively discharged, and the half equation is 2H+ plus 2 electron will be producing H2 in the form of gas. So hydrogen gas is produced at cathode. So the answer to this question is bubble of colorless gas will be formed at electrode 1, 2, and 4 because oxygen and hydrogen are both colorless gas.
For question number 2, diagram 2 shows the apparatus set up for the reaction involving the electron transfer at a distance. Which of the following statement is true? So to answer this question, we must first identify which solution is an oxidizing agent or reducing agent. By this, we can determine which electrode undergoes oxidation and which electrode undergoes reduction. As we all know, acidified potassium dichromate solution is an oxidizing agent. Thus, electrode X undergoes reduction, while iron 2 sulfate is a reducing agent, and so electrode Y will undergo oxidation. So my answer will be B. The answer A is wrong because the electron flow is from reducing agent to oxidizing agent. So electron flow should be from electrode Y to electrode X. D is definitely wrong since, as I stated earlier, acidified potassium manganate IV solution is an oxidizing agent.
For question number 3, it says that diagram 9 shows the apparatus set up to study the transfer of electron at a distance by using the YouTube. So before answering the question, we should understand the diagram first. As we can see that G symbol is present in the circuit, which means galvanometer is present in the circuit to know the electron flow from which electrode to another electrode. So the circuit have two electrode, which is both are carbon electrode, and at X electrode we have potassium iodide solution, and at Y electrode we have acidified potassium manganate 7 solution, and we also have dilute sulfuric acid, which is salt bridge to complete the circuit. So how before answering the question, we should know which electrode are anode and which electrode are cathode. So we will make the half equation for an electrode to know electrode are anode or cathode. So at X electrode we can see that it has potassium iodide solution. So it means that iodide ion are present. So iodide ion will become iodine gas when two electrons are released. So the half equation will be like this. When the half equation is stable, we can know that at X electrode it undergo oxidation process, and at X electrode it will become negative terminal, which is anode, and Y will become cathode. So we will mark the anode and cathode for both electrodes. So now we will answer the first question. The question say the half equation below shows the reaction occur at Y. Complete the half equation. So the question say that the blank half equation below is the half equation for Y electrode. So before answering the question, we should see from the right hand side. So as we can see, we will have Mn2 plus blank H2O. So what to put in front of the H2O? So we will see at the left hand side. At the left hand side, we can see that it has 4 oxygen from the MnO4. So the oxygen, so it means that it has 4 oxygen. So we will put 4 in front of the H2O. So the oxygen will now stable on both sides. So at right hand side, we can see that it has 8 hydrogen. So we will put 8 in front of the hydrogen ion. So the hydrogen will become stable at both sides. So how to know the electron? What to put in front of the electron? So now we will calculating the charge for the right hand side. As we can see, we have Mn2 plus, which means we have 2 positive charge, and we have 4 H2O, which means we have 0 charge because H2O is a natural compound. So for the right hand side, we have 2 positive charge. So for the left hand side, we have MnO4 minus, which means we have 1 negative charge, and we have 8 hydrogen ion, which means we have 8 positive charge. So when 8 positive charge are added with 1 negative charge, we will have 7 positive charge. So how to make the 7 positive charge become 2 positive charge? So by adding the 7 positive charge with 5 negative charge. So when 7 positive charge are added with 5 negative charge, the charge left are 2 positive charge. So the charge are stable from both sides. So the half equation at Y will become like this. MnO4 minus plus 8 hydrogen ion plus 5 electron become Mn2 plus 4 H2O. So question number 2. Based on your answer in 3C1, draw the arrow on diagram 9 to show the direction of electron flow. So first, we must know that electron flow from anode to cathode, which is from negative terminal to positive terminal. So we know that X is anode and Y is cathode. So the electron will flow from X to Y. So how to prove? We will draw arrow on the circuit from X to Y. So we will prove that electron flow from X to Y electrode, which is from anode to cathode, and electron flow in the circuit, not in the solution.
For question number 4, I would like to explain first the situation that is shown in the question. So as we can see, the iron nail is coiled with copper wire, and even so, the iron nail still rusts. This is because copper is less reactive than iron. So to prevent rusting from occurring, we need to replace copper with a metal that is more reactive than iron. So the metal that I choose is magnesium. Magnesium is a more electropositive metal. When an iron is in contact with more electropositive metal, rusting is prevented because magnesium will corrode instead of iron. The expected observation is that magnesium will corrode while iron will not corrode. Pink spot is formed from the penophthalene since OH- ion is present, while blue spots does not form because there is no presence of Fe2+ ions. Therefore, iron does not rust.
So for the question 5, the question asks us to draw the energy level diagram for the combustion of ethanol based on the chemical equation. So the chemical equation is already given. So the first step, we need to know whether this is an exothermic or an endothermic reaction. So we need to look at the delta H value. So the delta H value is negative. So if the delta H value is negative, then it is an exothermic reaction. So we know. So we need to draw the energy level diagram for exothermic. So this is the reactant. We just copy the reactant here and then we just write it back. And then this is the product. This is the product. We also do the same thing, which we just copy the product and then we just write it back. And we also need to write the delta H. So we already know that exothermic reaction, for the exothermic, the product is higher, the reactant is higher than the product. So this is how the energy level diagram looks like. So next, we need to predict whether the temperature of the surrounding will be lowered or raised, and we also need to explain the answer. So the answer is the temperature of the surrounding will raise because this is an exothermic reaction which will release heat to the surrounding.
For question 6.1, it asks us to calculate the heat of precipitation of magnesium carbonate. So I'll take you step by step on how to do the calculation. So first step is to write the chemical equation, and the chemical equation must be balanced. So the reaction involved magnesium nitrate reacted with potassium carbonate, which then will produce magnesium carbonate and potassium nitrate. The next step is to calculate the number of mole of magnesium nitrate and potassium carbonate used. By referring to the table in the question, we know that the concentration used for both magnesium nitrate and potassium carbonate is the same, which is 1.0 mole per dm cube, and the volume is also the same, which is 50 cm cube. So substitute the information into the formula mv/1000, and then we get number of mole for magnesium nitrate is 0.05 mole. The same goes to potassium carbonate. The third step is to calculate the heat change by using the formula Q equals to mc theta. So m is 50 plus 50 times 4.2 is the specific heat capacity, and 30 degrees C minus 26 degrees C is the change in temperature. So we got the heat change is 1680 joule. The next step is to find the ratio of mole. So by referring to the chemical equation that we wrote earlier, we know that 1 mole of magnesium nitrate reacted with 1 mole of potassium carbonate will produce 1 mole of magnesium carbonate. We are focusing on magnesium carbonate since the question asks us to find the heat of precipitation of magnesium carbonate. So therefore, giving them all the same number of mole, which is 0.05 mole. And lastly, we'll calculate the heat of precipitation by using the formula delta H is equals to Q over N. So Q is 1680 joule divided by the number of mole, 0.05 mole, and then we got the answer is 33,600 joule per mole or 33.6 kilojoule per mole. Heat of precipitation of magnesium carbonate is endothermic reaction because temperature of mixture solution decrease, in this case from 30 degrees C to 26 degrees C. Therefore, delta H is equals to positive 33.6 kilojoule per mole. Positive here indicates that the reaction is endothermic. So for question 6.2, it asks us to predict what will happen to the value of heat of precipitation if the potassium carbonate is replaced with the sodium carbonate. So my answer is that value of heat of precipitation will remain the same since the volume and concentration of sodium carbonate used is the same as the volume and concentration of potassium carbonate used, hence giving them the same number of mole. For question 7.1, referring to the table, we see that the heat of neutralization in set 1 is higher than the heat of neutralization in set 2. So, we can say that set 1 uses a strong acid and set 2 uses a weak acid. So, acid V is hydrochloric acid and acid W is ethanoic acid. For 7A2, the answer is neutralization reaction of set 1 uses strong monoprotic acid and strong monobasic alkalis, while neutralization reaction of set 2 uses weak monoprotic acid and strong monobasic alkalis. So heat of neutralization of strong acid with strong alkali is the highest or higher than the heat of neutralization when a weak acid or weak alkali is used. For question 7b, it asks us to calculate the change in temperature of mixture in set 1. As we can see in the table, heat of neutralization in set 1 is 57 kJ per mole. So to calculate the heat of neutralization, we use the formula Q over N. So Q over N is equals to 57 kJ per mole. So next is to calculate the number of mole of potassium hydroxide and hydrochloric acid used. Since both of them uses the same concentration and volume, we just substitute the value inside the formula MV over 1000. So 50 times 2.0 is equals over 1000 is equals to 0.1 mole. So now that we got the number of mole is 0.1 mole, and then we substitute this into the formula here. Q over 0.1 is equal to 57 kJ per mole. And then we calculate Q, so 57,000. This is from kilojoule to joule times 0.1 mole. And then we got the heat change is equals to 5,700 joule. So to calculate the heat change, we use the formula MC theta. Theta as in the change of temperature. So we substitute the formula that we already know. Q is equals to 5,700. M is 50 plus 50, C is 4.2, and then we need to calculate the theta. So to calculate the theta, 5,700 divided by 100 times 4.2. So we got the change in temperature is approximately 13.6 degrees C. For question 7C, the answer is as shown here.
Okay, so question 8, the first one, we need to draw the structural formula of polymer Y and state its name. So as you can see, the structural formula of the monomer for polymer Y is already given. To draw the polymer, we must follow a few easy steps. Firstly, draw the carbons. So as you can see, there are 2 carbons. So we need to draw 2 carbons, but instead of drawing them with a double bond, we draw them with a single bond. Next, draw the hydrogen. So I'm going to draw 2 hydrogen on this side. because on the diagram, it only has 2 hydrogen. For the right side, there are 1 hydrogen and 1 CH3. We now need to show that it's attached to other monomers. So I'm going to put 2 lines on the side of my carbon. After that, I will draw a big bracket around and then a small n. This small n shows that you've got lots of this repeat unit and this is only 1 repeat unit. So this is how to draw the polymer Y. The name of this polymer is polypropene because this is an alkene and it has 3 carbons, so that's why the name of this is propene. So if it's a polymer, then we need to add poly. To name it, we need to add poly in front of the propene. So the name of this polymer is polypropene. So for the second question, polymer Y is a widely used synthetic polymer. However, its usage has caused environmental pollution. Explain how the properties of polymer Y make it very useful, but at the same time cause environmental pollution. So my answer is, polymer Y is a non-biodegradable substance which can contribute to environmental pollution. Improper disposal methods and burning of polymer Y will produce a toxic and harmful gases which will affect human health. Polymer Y can be used for many purposes because it is an inexpensive material and durable.
Number 9, the following equations show how soap can be prepared. So it shows a reaction when palm oil react with concentrated alkali become material X plus soap. So question number 1, what is the name of above reaction? So we can see from the above reaction, the soap is produced. So the process producing soap is called saponification. For question number 2, the soap produced is potassium palmitate. What alkali should be used? As the product is potassium palmitate, the palmitate is come from the palm oil. And as the product is potassium palmitate, we should know potassium instead of sodium. And as it is alkali, we should use potassium hydroxide because potassium hydroxide is alkali and can react with palm oil to produce potassium palmitate. For question number 3, what is the homologous series of palm oil? Palm oil is an ester because it has COOC. So for B1, complete the anion part of the soap particle in the space provided. So we will draw after C we have double bond O, and we also have O minus ion and K plus ion. K plus ion is for potassium plus ion.
So for question number 10, the question is, nanotechnology is a technology that is now being developed and also applied in the field of cosmetic. Based on the statement, explain how the effectiveness of cosmetic materials that use nanotechnology to consumers. My answer is the small size of the nanoparticles compared to particles in conventional emulsions allows the nanoparticles to penetrate deeper into the skin, so it can deliver the nutrients to more layers of skin cell. So by using nanotechnology in cosmetic, the effectiveness of cosmetic will increase.